So let's get going here. So this first one was about the conversion of using morphine milligram equivalents. So the patient is in the hospital now, a 58-year-old male patient who weighs 143 pounds, has been needing morphine 5 milligrams IV. What's another word for IV? Looking at the table there. Parenteral. So parenteral means IV. Every 3 hours to control the pain. Okay, so we'll come back to this conversion table. First thing he just wants to know, okay, what is the total daily morphine? What has he been using total per day of morphine? That should be pretty straightforward. Per day, 24 hours, he's taking 5 milligrams, every 3 hours. So there's my conversion there. So 24 hours times 5 divided by 3. Hopefully you got 40 milligrams per day. Pretty straightforward. But I'm keeping my units there of what? 40 milligrams of IV morphine. Don't forget that. You're going to need that here in a minute. Okay? Because now the more complicated part of this question is, well, convert that from IV morphine to what? Oral oxycodone. Not just oxycodone, but what kind of oxycodone? Oral oxycodone. Okay? So we need a conversion from IV morphine to oral oxycodone. All right, so where would we go? Let's go back to this table. Well, parenteral means IV. Oral over here means oral. So here's my morphine. Was it oral or IV? It was IV morphine. So 10 milligrams of morphine IV is equivalent to what? Now let's go to oxycodone, but over here to oral, I would argue it's equivalent to 20 milligrams of oral oxycodone. So my relationship is 10 milligrams morphine IV to 20 milligrams oxycodone oral. So that's really how you solve this question here. So my total that I just solved for 40 times, again, 20 milligrams of oral oxycodone goes on top because I need to cancel my morphine milligrams on the bottom. So 40 times 200 divided by 10 gives me a total daily dose of 80 milligrams. However, it's a new opioid, so I need to reduce the dose by 25%. I'll remind you on these questions that how much to reduce it by is not useful. Mathematically, what we need is how much remains. So if we reduce something by 25%, we start at 100 and go down by 25, that means we have 75% remaining. So all we have to do is take my total daily of 80 milligrams times 0.75 or 75%, and that changed my 80 down to 60. So my final answer for part 2 would be 60 milligrams per day of oral oxycodone. Now, how many tablets? And there was confusion on this question. My answer here is for how many tablets per day, and I'll talk about that. So how many tablets per day? Well, if they're doing 60 milligrams per day, okay, and they're doing it every 6 hours, and this was a little tricky. So how many doses per day? There's not 6 doses per day every 6 hours. How many? What is 24 divided by 6? 4. So there are 4 doses per day, okay? So that will, then I have 1 tablet is 5 milligrams. So essentially I got to take my 60 and divide it by 4 to get the number of doses per milligrams per dose, which is 15. 15 then divided by my 5, so the milligrams cancel there and days cancel, and I get tablets per dose. So 15 divided by 5 is where I got my 3 milligrams per dose. If you went ahead and didn't do this part and came up with 12 milligrams per day or 12 tablets per day, that was a fair answer to this question, since I didn't really clarify whether it was tablets per dose or per day. But again, hopefully you got 3 tablets per dose. If you're doing it 4 times a day, that would be 12 tablets per day. Okay. All right, now they have been on that for a while, but they got their creatinine clearance back and they seem sedated, so maybe our drug isn't being cleared fast enough because of the renal function. So let's calculate the renal function. What could possibly go wrong with this? Again, if you're not careful and doing the gender thing, but it's a male, so we will not apply the 0.9, so just do your age, 58, and do the math correctly using the serum creatinine. And did everyone get 35? Okay, so 35 milliliters per minute. So we look at what the drug information tells us and says, okay, instead of doing it every 6 hours, just change the frequency, not the dose, but the frequency to every 8 hours. So we're going to keep the same dose of 15 milligrams, but not every 6 hours. We're going to do it every 8 hours. Would that be less per day? Yes, and that way they're not over-sedated because their kidneys aren't removing the drug as much. Okay? All right, let's move on to the chapter 6 question. So this was all about concentrations. So given that prescription there, I'm going to keep moving on and you can refer back to it. Hopefully you have it in front of you. So starting with the zinc oxide, the easiest of the bunch, it was 12.5%. Zinc oxide is a solid. We're making a cream, so that's a solid. So that's a 12.5% is a weight per weight concentration. So given that I'm trying to make 240 grams of cream, 12.5 grams of zinc oxide per 100 grams of cream. If I multiply like that, so creams cancel, then I have weight of my drug. So multiplying that, I got 30 grams of zinc oxide. And since it's pure zinc oxide powder, that's all I got to do. And I set that up because it's a little more difficult for the chlorbutanol. Okay, but let's just do the same first step to begin with. I would argue right here, if we stop at this point right here, this is what we just did in the previous question. We took our weight of our cream times our concentration. But now the concentration was given as a 1 to 200, a ratio strength. Chill, it's okay. It's just like a fraction, 1 over 200. And since it's a weight per weight, the weight of the drug per the weight of a cream, then it's grams per gram. So I would argue a 1 to 200 means 1 gram of my drug chlorbutanol for every 200 grams of my cream. Now, if I know how much cream I'm multiplying by, I can just cancel that out. So basically 240 divided by 200 gives me grams of chlorbutanol. This question is made more difficult since the source of my drug is not a pure drug powder, it's a 20% weight per volume solution. So I have to use that concentration down here to actually calculate the volume of that liquid I need that provides my chlorbutanol. But 20% means 20 grams of drug per 100 milliliters. Since I have grams of drug here in my numerator, I'm going to multiply by 100 mils over 20 grams. And that way when I multiply that across, then grams cancel and I get milliliters, or a volume of my chlorbutanol solution. Okay? So that's what I'm going to measure is 6 mils of that liquid. That will provide me the chlorbutanol I need. However, I need to know its weight. So I'm going to start with that volume and use the specific gravity, which is equal to density, so long as I use grams per mil. So a specific gravity of 1.1 means 1.1 grams per mil. If I multiply 6 by 1.1, mils will cancel, and I will know the weight of that 6 mils. So 6 mils weighs 6.6 grams. And that was my answer for number 2. Okay? Number 3 was a pretty straightforward one. It gave me the grams of glycerin, but I'm going to measure it by volume. Glycerin is a liquid, so how many mils do I have to measure? Well, 19 grams times its density or specific gravity, but expressed so that my units cancel. Now I don't want to go from a volume to a weight, I want to go from a weight to a volume. So I'm going to multiply by 1 mil over the 1.26 grams so that grams cancel. So 19 divided by 1.26 is why I end up with my volume of 15 milliliters. So I know the volume of that liquid to use. Okay? I know it's going to weigh 19 grams, but that 19 grams has a volume of 15 milliliters. And I emphasize that here because the last question with the Vanicream wants to know the weight of the final ingredient. It's the weight, since it said QSAD means a total weight of. If everything weighs 240, then you take the 240 and you subtract what? Everything else. So take the total of 240 minus the weight of the zinc oxide minus the weight. What could go wrong there? What number could you use? 6 milliliters. Would you agree? Do not use 6 mils. We need to subtract the weight of 6.6 grams. That's why you had to find it. Okay? And then remember, for the glycerin, even though it's 15 milliliters of liquid, the weight was 19 grams. So make sure you subtract the weight. So by the time you subtract all of those weights, it's 184.4 grams of Vanicream. All right? All right. This one, I say I love this question. This one is absolutely a endless practice problem. I just put on paper. So again, I obviously like this kind of question. So make sure you can do it. All right, so we got some patient specifics. A 26-year-old male who's 5 feet 6 inches tall, weighs 132 pounds, has been prescribed spironolactone. I love my drug names. 790 milligram dose IV every 4 hours. And I give you his serum creatinine. Okay? We said serum creatinine above 1 is a little concerning. So again, if it's got a value of 2.8, is that kind of high? That's kind of high, so definitely thinking we should calculate the creatinine clearance to make sure his kidneys are functioning. So, because we do know this drug needs to be adjusted depending on the kidney function. So let's start by calculating his creatinine clearance. I will, again, tell you, I will provide you the formulas. You do not need to memorize any of these formulas. Just use them correctly, and especially about the gender aspect. This patient is male, so we don't have to worry about that part of it. But we have to take his weight, 132 pounds, and divide by what? I skipped that step for you. 132 divided by the 2.2 pounds per kilograms. That converts it over to kilograms. He's 26 years old, so there's the age, and the serum creatinine is here, so that just got plugged into the formula there. By the time you solve all of that, I got 34 milliliters per minute. Okay? Pretty straightforward. Just use the formula, but make sure you put the right numbers in there. That's all I'm saying. Make sure you're careful with your units and all that. All right, 34. Well, now going back to here, let me just say this here. So 34 is where? 34 falls into this range right here. And I want to emphasize something. The reason I ask this question is because it forces you to adjust the dose two ways, both by the amount. So see this 790 milligrams? That's the dose. You see that every 4 hours? That's the frequency. When you adjust drugs for renal function, sometimes you adjust the dose, sometimes you adjust the frequency, like we did with the oxycodone one we did earlier. And in this case, we have to do both. Would you agree? I'm just trying to point that out here. Our adjusted dose will have to be 75% lower on the dose and every 5 hours, not every 4 hours. All right. Now, before we do that, the easier one, I would argue, is the original daily dose. So how much was this person getting per day based off of the way it was prescribed? Well, it was basically 790 milligrams every 4 hours. So again, 24 divided by 4 is what? 6. So there are 6 doses per day. So essentially 790 times the 6 gave me a total daily dose of 7440 milligrams. Okay? Is everyone okay with why I did this? So it's every 4 hours, so that's down here. But I want it per day, so there's 24 hours in it. I should have crossed it out, but 24 hours per day. Anyways, that means there are 6 doses, so 6 times 790. Now, this is where I worry about you, and I wanted to do this one in class together. Certainly the endless practice problem shows you this on the key. The easiest way to adjust this is to do it in steps. So remember, we started with our dose. So our 790, though, is only how much? 75% of that dose, so 0.75 times the dose, and then it's still 24 hours in a day, but now our new frequency is 5 hours. So it's 24 divided by 5 will get you the frequency, but it's 790 times 0.75 times that frequency. Okay, so here's my dose adjustment, and here is my frequency adjustment. So make sure you adjust both of those so that you can see the daily adjusted dose is going to be 2,844. I would say, when I have used this question in the past on exams, this question here gets trashed. Okay, so make sure you know how to do that because it's confusing. You'll just take your total daily times 0.75 or something. You won't adjust the frequency. You'll just adjust the dose, and that doesn't work. So make sure, I asked this question on purpose to make you adjust both the dose and the frequency, if you consider this part here. So those two things have to be adjusted to calculate it correctly. Okay? All right, moving on. 2 patients here, so for the sake of time, I might just do one and show the other one kind of quickly here, but daunorubicin, a drug. The trick on this one is it's BSA dosing. If it's less than 0.5 for a BSA, it's weight-based dosing, I should say. But if their BSA is greater than 0.5, then you use body surface area dosing. So obviously, we're going to have to calculate the body surface area to know how to dose it first. So then I give you the body surface area formula right there, big and bold. So how would you go about this? For a patient who's 12-month-old, who is 30 inches in height and weighs 22 pounds. So body surface area first, determine which dosing regimen to have to use. Okay, so let's do the body surface area first. I hope you're good at this. We've practiced this quite a bit, so hopefully this is not a big deal. Body surface area, though, needs the weight in kilograms and the height in centimeters. So that your first step is to take 22 pounds divided by 2 pounds, 2.2 pounds per kilogram, to convert pounds to kilograms. So this child actually weighs 10 kilograms. The 30 inches is essentially converted to centimeters by multiplying by 2.54 centimeters per inch. So now I know their height in centimeters. So that's where the 10 kilograms comes in, the 76 centimeters, and then your careful math on your calculator. I worry about you a little bit with the square rooty thing. Worry with me on that, so make sure you're okay computational-wise that you can do this. But basically 10 times 76, 760, divided by 3,600 first, 0.21. Then take the square root of that, and I got 0.46. And since that is less than 0.5, then we're going to use weight-based dosing. So the weight-based dosing was 1 milligram per kilogram. So remember to use the weight in kilograms times 1 milligram per kilogram gives me 10 milligrams. Then the last thing was to convert that to how much drug solution to use. Well, the concentration of the solution was 20 milligrams per 4 mils, and that was given in the question. So to get a volume, I need to multiply the milligrams times 4 mils over 20 milligrams, so that milligrams cancel. And clearly, to provide that, I need 2 milliliters. All right? Now, the next question, the only difference here was by the time you did all of that same work, their body surface area turned out to be greater than 0.5. So since it's 0.62, it's body surface area dosing. So we used their body surface area that we just calculated times the 25 milligrams per meter squared. That gave me 15.5 milligrams. Same drug concentration. So again, times 4 divided by 20, and I got 3.1 mils. Okay, so the questions work exactly the same, but certainly it was dependent. And on the exam, I guarantee you only will have to do one question, but it could end up with either one of the dosing. You usually have to calculate something first. Like ideal body weight. So in this question, or in this case I should say, body mass index. So based off of the body mass index, you'll either use actual body weight for non-obese patients or use ideal body weight for obese patients for this acyclovir dosing. So clearly we have to calculate the BMI first and then use either actual or ideal depending on what the results are. Okay? And then it still gives you a concentration there. So let me kind of go through quick here. I'm running out of time. So, but let's do this slower. So, as a reminder, this formula will be given, but their weight in pounds, the 253 here, is converted to kilograms by dividing by 2.2. So I know this patient weighs 115 kilograms. Now I need their height in meters and not centimeters. So I'm going to take 5 feet, 8 inches, and take 5 times 12 is 60, plus 8 tells me his height is 68 inches. But I got to convert that to meters by the conversion I gave you. Oh my, that's, well, for 1 meter, I'm sorry, that's right. It's 39.37 inches. So divide 68 by 39.37 to get their meters is 1.73. Now again, you have to carefully calculate BMI, which is again their weight in kilograms divided by their height in meters squared. So don't forget to square the denominator. So you have to take 1.73, square it before you divide it into the 115. When I did that here, I got 38 milligrams per kilogram. What was the key? Was 30, right? Greater than 30 is considered obese, so we'll consider them obese. Therefore, we have to use their ideal body weight for the dosing. We haven't calculated that. So now let's get the ideal body weight. I'll warn you, I will always give you both gender formulas. Which one do you have to select? The correct gender. Just make sure you do that. So again, this is a male, so it's 50 kilograms plus the 2.3 times the height in inches. So remember, over 5 feet. So whatever the height in inches over 5 feet, so he's 5 feet 8 inches, so 8 times 2.3 plus 50 gives me the 68.4 kilograms. And that's my weight that I'm going to use in my dose. Finally, I know what to base my dose off of. So 68.4 kilograms was 10 milligrams per kilogram, so that's easy. That's 684 milligrams. This is my concentration of the injectable, so remember we're going to set it up so that milligrams cancel. 684 times 10 divided by 500 gave me 13.7 milliliters. This kind of worked the same as the previous one. Here we had to calculate BMI instead of BSA, all right? But we had to do that. We made a decision, choose our right dosing based off of that, and then just multiplied it across. This one works exactly the same way. I'll just mention here, though, when we did the BMI, it came out to be less than 30. Since they're non-obese, we're going to use their regular or their actual body weight, not their ideal, so we don't have to calculate it. So we'd use the 75 to calculate the dose the same way. All right, we're getting to the last question here, and everyone's favorite Henderson-Hasselbalch. Again, on this question, if I give it on the test, it's a matter of just doing the computation correctly on your formula, on your math, okay? And we'll see, it's not always that easy. I would argue number 1 here is the easiest of the bunch because I'm going to give you 2 out of the 3 variables, all right? There are 3 variables here. There's pH, there's the concentration of the bicarbonate, and there's the partial pressure of the carbon dioxide. 3 variables. I will give you 2. You have to solve for the 3rd. This one's the easiest because it wants for the pH. So all we have to do is put in the formula. So in this case now, my bicarbonate concentration goes here of 27. My partial pressure of carbon dioxide goes into that part of the formula. And let's just solve for it. So this one is usually easiest for people. So you start with 0.03 times 30. Okay, you multiply that and it gives you 0.9. Then you take 27 divided by 0.9, and that gives you 30 here. Okay, then you take the log base 10 of 30 on your calculator, and that gives you 1.477. Add that to the 6.1, which is a constant here. It's essentially the pKa of carbonic acid in the blood. So that will always be that in the formula. So you add those together, and I got a pH of 7.58. All right, that was an easy one. The last question here, and I know I'm almost out of time here, but let's see if you could do this. This worries me. This is kind of an algebra. It requires decent algebra, and it requires a little bit of computational knowledge. So bear with me on this. It's the same question. Now I'm giving you the bicarbonate concentration, and I'm giving you the pH. What are we needing to solve for? The partial pressure of carbon dioxide. So let's set that up. So what does this become? That becomes X. Oh, that doesn't even look like an X, but I'm rushing here. Okay, sorry. So do this. Make sure you get this formula here. Does that make sense? Because I put in my value for the pH, I put in my value for the bicarbonate, and I put X in for the partial pressure of the carbon dioxide. This is kind of messy. Would you agree with that from an algebra standpoint? So trying to solve for this, I'll try to explain first. We want to isolate the X on the right side. So let's get rid of this number by subtracting it from both sides. So I subtracted 6.1 from 7.36. That's where I got the 1.26. And that's why I don't have a 6.1 on the right anymore. Is everyone okay with that? Now, geniuses here, this is where you haven't done this for a while. How do you get rid of a log? This log has got to go, man. So to cancel the log on the right-hand side, what do I have to do with my 1.26 on the left-hand side? 10 to the x. Log, log of log base 10, its opposite function is 10 to the x. Like a natural log, what's the opposite of a natural log? E to the x. Okay, I'm getting blank stares. Anyway, so to solve this question here, I've got to take 10 to the 1.26 exponent. That's what I did. By taking the left-hand side and doing 10 to the 1.26, that cancels out the log. So make sure you understand how to cancel a log by doing 10 to the x. So 10 raised to 1.26 is 18.197. That cancels the log, and you get rid of the parentheses, and now it's a pretty straightforward algebra problem, but still, you've got to reverse these two. So I'm going to cross-multiply and switch those. So again, 0.03 times x would be equal to the 24 divided by the 18.197. That divides out to 1.139. Then all I have to do is subtract 0.03 from both sides. Or no, not subtract. I said it wrong. It's multiply, so what do? Divide that by that. So I have to take 1.319 divided by 0.03, and that's where my final answer of 44 comes from. All right?